Okay, I think we are good to go. Hi, everyone. Thank you so much for having me here at Vox's Microservices. It's a real pleasure to be here with you, and thank you so much for attending this session, especially considering there are other sessions happening that are quite as good as well. So my name is Roberto Cortez. I'm coming from Portugal. I'm a Java champion. I've been working a lot with microservices for the last couple of years. So that's why I came up with this talk. And please, here are my contact details. So feel free to reach me out if you need any help after the session, or if you think that I can help with anything that you hear here, or anything else that you think that I can help. So our agenda for today, of course, we're going to talk about microservices. That's what we are here for, right? We're going to talk a little bit what GraalVM is. We're going to have a look into what is MicroProfile. And I'm going to fill this with a bunch of demos that I hope that can be helpful to you as well. OK, so microservice, anyone? Who's here is doing microservice? Right? So we're Vox and microservice. So I hope that anyone here is not doing microservice. OK, there's a few. So maybe this is not the right conference for you. Or maybe if you just want to start, maybe that's a good conference for you to come. Anyway, I quite hate them. So anyone here likes microservices? Come on, we're in a safe environment. That's fine. So yes, I mean, pretty much, I think that if you want to get accepted in conference these days, you have to talk about microservices, right? So I mean, those are probably some of the questions that you do about microservices. Since we are on a microservice conference, I'm going to skip a little bit of that. But I like to share some of the things that usually people answer to me when you talk about microservices on Twitter. So this is one of my favorite ones, right? And architect dream, developer nightmare, right? I'm now working on a company called Talkdesk, and I'm now a software architect over there. So now I get to do those kind of things, which are pretty fun. Right? So now I just tell people to do stuff, and they'll do it for me. One day microservices will share some wisdom called servlets. Right? OK. So let's moving on. So the reason why people came up with microservices, they say, OK, let's do little features quicker, smaller agile teams, right? Yada, yada, yada. It's all the same thing. So I'm going to skip that one as well. But the thing is, I like to call this my personal microservice hell, right? Because people will just say, oh, start building microservice, and now you can start build any service on whatever language you like, right? So now people start building a service in Java, another will build a service in Node, another builds a service in Ruby, another people, and I see people nodding and laughing because I'm pretty sure that you have your case in your companies, right? And then it's a hell to maintain, right? Because then you require different libraries to cover the same features across all the different languages. There is an increased complexity on all around. So you want to do security, you have to find each library for each language to do security, or you have to write your own, and you have to write it 3 different times. And you have to maintain it on 3 different languages. If you're using 3, if you're using 4, then that's 4. And it is a hell, right? So there is a lot of research time involved. Are you familiar with these? Are you having these pains? A little bit? Yes? OK. So everyone knows that the Indiana Jones already found the Holy Grail, but I wonder if we need to find the Holy Grail of programming languages. And maybe there's something that can help us, and that's called GraalVM. So don't you know what GraalVM is? A few. So let's talk a little bit about it. So GraalVM, it's a VM made by Oracle. It's called a universal virtual machine. And the idea with GraalVM is that you're able to run JavaScript, Python, Ruby, even C, and of course all the JVM-based languages in a single VM. How does that sound? Does that sound cool? Does that sound impossible? Well, no, I'm saying here that you're able to do it now, right? So I wouldn't be standing here if that was not possible. But they've been working for this for quite a while, and over the last couple of years, they've made a tremendous amount of improvements and advancements. And they came to a point where you're actually able to run Polyglot stuff on your applications. So you're able to mix stuff like Java, JavaScript, Python, Ruby in the same VM. And I'm going to show you a couple examples on that. So a lot of people are hearing about GraalVM. They're mostly hearing about the performance improvements and the native image compilations. And those are awesome features. But the things that I'm actually looking for is the Polyglot stuff, because I think that it'll solve a couple of things that you usually struggle with. OK, so a little bit about the GraalVM architecture. So the project started up with something called the JEP 243, which is a JEP that allows you to plug in your own compiler to JVM. And then the project scope actually increased a little bit. So they created something called the Graal compiler, which is able to support Java, Kotlin, and Scala, and pretty much any other JVM language. And then they'll plug in something called Truffle that actually allows you to express as an abstract syntax tree any other language. So as long as any other language would like to be supporting GraalVM, if they implement their Truffle representation, then they're able to execute at the same level as any other language. So then you're able to mix everything up. So that's just a really high overview of what GraalVM gives to you. So to show how GraalVM works, I'm not going to install this because I already have that installed. But let me show you. So you can use SDKMon if you don't know it. It's quite useful when you want to generate to install multiple VMs and manage them. But in here, let me show you here a quick example. So in here you have a Spark. Are you guys able to see this properly? Is that OK? Wonderful. So you have here a Spark application that's only starting up a REST endpoint on that number API /number/generate that's generating a random number, maybe for you to generate the SPN to create a book. Doesn't really matter. I'm actually using an API of MicroProfile config to set up the port where I want to run that application. And this is just plain Java, nothing out of the ordinary. So if I compile this, I already have that compiled as a jar. So not that one. So I'm not going to build that, so I'm just going to run it. So if I do java.jar, and that's target number API.jar, and then you have your application running. And of course, now I can curl that one. And that one's running on 5001. And there's a number, so that works fine. So it seems to be like any other Java application that you run, and it is. So if you do a Java version, this is just running OpenJDK, the GraalVM version. So I just installed it, just run as any other JVM. It has a Java C, a Java binary. So you can run pretty much any Java application from here. So nothing out of the ordinary from now, right? OK. So moving on. So why GraalVM? First of all, I like the interpretability capabilities of GraalVM. Again, you're able to mix different languages and call polyglot stuff on that. And we're going to show you how. You can reuse libraries. So the idea here is you can pick up any library that you will like. Well, it will work most of the cases. There are some cases it doesn't work, but they'll get in there. But you can pick any library that you got from JVM, from Node, from Python, and then you can use it on your code. I'll just say you can pick a Java library and use it from Node, or you can pick a JavaScript library and use it on Java. Does that sound crazy? How does that sound? I'm going to show you a sample that's going to get crazy, because I'm going to start the CDI container from Python. Shared tools. So since this is running on the same VM, you can just debug all your code from a single place. So you can see all your Python code, all your Ruby code, your JavaScript code, all your Java code, and run it and debug it from one place to another. Run Java faster. So because of all the optimizations coming from GraalVM, you can run Java faster, maybe around 20%. That's what the initial performance reports show us. And then you have all the native images, so you can compile your application to native image and run it without the VM in place. And it's even way more performant than just running the regular VM. So interoperability, how are we going to do that? So it has like a very weird syntax. And then on the Java side, it's a little bit better. But this is the JavaScript version. So in this particular case, what I do is I say, I want the Java type called java.io file. And then I extract that to a variable, and that's JavaScript. And then from that variable file, then I can call the constructor on file class, and I can pass there a file text. And that's going to create a file instance of Java in JavaScript. If I want to put that on a single line, I can just do new Java type, and then I can pass that on a constructor over there. Or if I want to call static methods, I can just say Java type java.io file, and I can call the static method directly with dot. That's weird, right? A little bit. Now, what you have to be careful over here is, if you want to run Java stuff on Node or Python or Ruby, then you have to use the binaries coming from the GraalVM to run all of those things, because I mean, you cannot just pick up plain Ruby or plain Node and just try to run it. No, there is a couple of arguments that you have to pass in, and one is like the JVM option, and that what's going to mean is it's going to run Node in JVM mode. So it's going to be exactly the same. You can pick up any Node application, equal pretty much everything that they support right now. And then you can pass a class path. And that means it will going to load that library into the class path on the JVM that's running Node. And then you can pretty much use any class coming on that jar if you want to load stuff from a jar file. If you just want to use simple APIs from the JVM, you can just run with the --JVM. Now again, so there is this web page that's on the GraalVM website. So the support level that I do to all these packages and all these libraries, it might depend, of course. There is one thing is about supporting the syntax of the languages themselves, like Python, Ruby, or JavaScript. That's the easy part. The hard part is actually able to support the libraries that exist on the ecosystem, because sometimes they do very crazy stuff that they're not expecting. So for my experience, stuff like JavaScript, Ruby, and R are very well supported. So you can come over here and see, oh, I want to use this library, and can see what the compatibility is with the current GraalVM version. So as you can see, they already support, for instance, SQLite. They support 100%. So you can use it on your projects, no issues. So just come over here and search. But things are improving, and they do support a lot of stuff. And if you find something that's not being supported, you can just come over here and report it, and they'll look at it and try to support it right now. So native images. So on native images, you can just do something like native image, pass in a class path, and you can say what's the main class that you want to support, or you can just pass in the jar directly. So these are really low-level commands. So when I start this presentation, there was not many tooling around. Now there are a couple of frameworks that does this for you. But I still find it interesting that you learn a little bit about what those commands do. OK, so now I'm going to run that as a native image. So let me check that out. So I already have a native image over here. So that's that number API. So I'm going to do something that you should never do. I'm going to cut that, right? So that's binary, right? You believe that's native. OK. So if I run that one like that, you have the exact same thing. So, and it will just give me the number again. That's just fine. So nothing out of the ordinary again. So you have the native image. I haven't shown you the actual build of the native image because it just takes 2 or 3 minutes to build, and I don't want to waste your time with that. So now we're improving. So we have a Java application. We now build it as a native image. So we're seeing some of the GraalVM capabilities, but I think we can do more. So let's have a look into MicroProfile. So MicroProfile, it's an open source initiative or an open source project with initiative coming from a lot of companies that wanted to build something to allow people to express and make it easier to develop microservices in Java. So it's a project held on Eclipse. Who here heard about MicroProfile before? Okay, if you anyone using it? No? Well, a few at least. Well, I hope that after this you can have a better look. But some of the things I'm going to show over here, you can even use it with Spring, so it's not really that difficult. And MicroProfile started in 2016 with version 1.0, which only had CDI, JAX-RS, and JSON-P. And now it's on version 3.0 since June 2019. And over those last 3 years, the project came up with specifications to do configuration, fault tolerance, job propagation, health check, metrics, open tracing, open API, and REST client. And later on, JSON-B was also added, coming from the Jakarta initiative as well. So there's a lot of work being done over here, and there's a lot of other specs being worked on right now. So I do like the way that MicroProfile gives an environment to you to help you build microservices. But how do you mix both together? How do you pick up some of the interesting things about GraalVM and some of the interesting things about MicroProfile and mix them up? So let's see a little bit. So those are some of the companies supporting it. So let's have a look on how we interpret GraalVM and MicroProfile. Okay, let's just think about configuration, right? So any application that's a microservice requires configuration, right? So if you do this in Java, for instance, you may use something called MicroProfile config, or you can use maybe Spring config. Doesn't really matter. But now you go to other environments, and then on Node, for instance, I'm not a very Node expert, but when I was searching, I found something called Node convict that seems to be the standard way to do configuration on Node applications. I'm not sure if anyone agrees or not. And in Ruby, I found something called .env. That also seems to be the standard way. And now you see you have an issue over here because you have 3 different services, and you have, or you're trying to build services with 3 different languages, and now you have 3 different libraries to do the exact same thing. But do you believe that those 3 libraries are going to do the exact same thing? No, they're going to have different features. Some of them are going to do similar stuff, right? And then if you move from project to project, then you have to relearn all that stuff. On configuration, if you do MicroProfile config, you can just do something called config provide get config, and then you can just retrieve configurations from environment variables, system properties, or you can set up your own config source. So that's pretty convenient. Now, as you're seeing right here, I actually put it up here a configuration that I'm retrieving from the config provider, which is number API port. And I can set that up with an environment variable. So if I now do an export and I say 510, now it changes the number API port of my application. So if I run the Java jar, right, now that's running on 510. Right? So if I try, oops, that was not what I wanted to do. If I try and curl it, that's not going to work. And if I go and do that one, now that works, right? And this even works with, let me clear it. That even works with the native image. So if I run the native image, now running on 510. So now I was able to plug in MicroProfile config, run it as in native mode. And you can pretty much configure your native image application using MicroProfile config with environment variables. So if I do a curl again, that's OK. That works. OK. So now we're going to go to some more interesting things. So now here I have. So let's just say I have a person in my team that doesn't like Java and likes to write stuff in JavaScript. Some people are laughing because probably that's true. And now they say, I don't want to write that Java crap. I want to run my JavaScript version. So then I came up with this Node application. Let me increase this a little bit. This Node application that's using Express to expose that same REST endpoint. But notice what I'm doing over there. I'm using the Polyglot stuff from GraalVM. I'm retrieving the config provider from MicroProfile config, and I'm getting the configuration from that object. and I'm using it to configure my JavaScript application. So now I'm able to use the same library across different languages without having to worry about, okay, now I have a different library, I have to learn how to use it, it's not going to behave the same way. No, it's going to be the exact same thing. And now, if I come over here and I kill that one, and if I run the JavaScript version, so let me search it over here, it should be around. Oh, that's a native image. That's the Ruby version. OK, Node. So now you see that I'm running the binary from Node that's coming on GraalVM. I'm passing in the JVM option and JVM class and the VM class path, which I point into the MicroProfile jar. That's where the MicroProfile config object is coming from. Then I even able to set up a system property for the VM to set that up as a system property, and I'm running the number API JavaScript. So it does take a little bit longer to start because I have to start the VM as well. But now you see that the JavaScript version started up, and now it's running on 3001. And again, if I do the curl, so now you have the exact same thing, but now running as a JavaScript version and the same library. And for the Ruby lovers, I also have here the Ruby version. So pretty much similar. Now, instead of using Express, using something called Sinatra to expose the REST endpoint. And again, it's picking up the MicroProfile config, retrieving the value, and then I'm setting up the value to set up the port to run Sinatra on. So if I kill that one and now run the Ruby version, let's do it like that. Not that one. So actually, I can even come over here and just change Ruby. And this is RB. So it does take a little time to start as well because starting at VM mode, so it's an annoyance, but I believe that the amount that you gain by just reusing libraries does pay off. So now you're running the Ruby version, that's running on 3001. And if I run that one, so yeah, you get the number. And if I kill that one and I run the JVM, the JavaScript version again, let's remove that system property. And I was going to pick if you remember, I set up our environment variable 510, right? So now it's going to pick the environment variable. And of course, that one is running again. So now you see I have three different versions of the same code. It can be something else, doesn't really matter. But the point here is I use the same library on 3 different languages to do configuration. And it doesn't have to be configuration, it can be wherever you want. So that's the idea. You can use the Polyglot capabilities of GraalVM to bridge between languages to one to another. And the cool thing about this is when GraalVM is doing all of this bridging, it's not copying objects from side to side. So the objects that they create is one single object in memory. So when different languages are accessing to the same objects, they're accessing to the same memory portion. That just have different representations of the object for that particular language. Meaning that when interoperability is just super fast, because everything is wrapping in memory, there is no conversion, there is nothing, right? Now, when you want to interoperate between different services, what do? Right, you have a JavaScript application, you have a Java application, how do you communicate between them? Yes, you use serialization, you use REST. You use JSON, you use XML, which are super slow, right? With GraalVM, this is just easy and fast because everything's happening in memory, right? And especially because you want to communicate with both services, you end up to develop a huge bunch of code and have to deal with serialization and deserialization and objects over the wire just because the language cannot talk with each other. But now, GraalVM might be able to solve that issue. Okay, so let's move on. And let's give you another example about fault tolerance. So fault tolerance is something that came out on MicroProfile as well. It allows to support secret breakers, timeouts, retry policies, fallbacks, and so on and so forth. So again, for Java, I find something called MicroProfile fault tolerance, but there are others like Easter eggs. There's one that's one being made by Netflix and came on Spring Boot. And on Node, I found something called Opulsum, and on Ruby, there's secret blocks. So again, same issue. You want to do fault tolerance on all your applications, and you have 3 different libraries you have to deal with. So it's a pain. On Java, this will look something like that. You'll annotate your method you want to call with circuit breaker and with a fallback. If you want to fall back to something else. So nothing out of the ordinary over here. And then this is the implementation of the fallback. So if your service is down, you can just fall back to a different number if you're not able to generate one. And then you can maybe asynchronously go over there and replace it. And then I'm going to combine this with REST client. So REST client is also coming on MicroProfile and allows you to have a static way and a safe way to call other services. So it's inspired by Feint. So if you use Feint before, it's going to be very similar. So there is also, even though the names are very similar for Node and Ruby, there's also common Node REST client and Ruby REST client. The way they operate are very different, right? So again, in Java, you have something like called register REST client. You pass in an interface. You add paths. You add your get methods and your subpaths and whatever you want. And on runtime, this is going to generate a proxy that's going to be able to call your REST endpoint over there. So now, I'm going to show you over here is I created here what I call a number API client. And my number API client has just this API. That what it does is calls the number service. And this number service is just the REST client that I show over here. Let me increase this a little bit. Okay. And the client just has the interface to be able to call that particular endpoint. So the one that I have running on JavaScript, Ruby, or native, I can call it this way. And here's my fallback, so nothing out of the ordinary. So I just generate a jar out of this. And so I can, let me run the native image. So let me just remove that export. Let's run the native mode. And here I have an invoker. So one trick over here is all of these things of REST clients, now you have to start seeing interfaces, see inject stuff, so these usually require CDI. So if you want to try this on JavaScript or Ruby or wherever, you require a CDI container, right? Because then you're not able to inject beans or run all those interceptors. Well, I can show you I'm able to create a CDI container on Ruby or Python and then run all this code over there. So what I'm going to do over here is I'm going to call that. So this is going to be the Python version. So it's going to call GraalPython. So the Python is not called yet just Python, just called GraalPython, but it's the exact same thing. So you pass in the JVM mode, the class path. So it's passing in a couple of additional jars, the one that has the client. And now it's passing a couple of configurations to tell where the service is running. So it's running on 5001 over here. So let's change it for 3001. And that's running. So let's run that GraalPython. So it does take a little bit to start. But now you see it over there. It's tried to create a CDI container, and now injecting all the beans, and then calling up the code on the REST client. How cool is that? So let me show you the code. So basically what I'm doing over here, let me increase it a little bit. So actually start a programmatic CDI container to be able to retrieve beans. So this is using the Open Web Beans from Apache. So it starts up, so you have to look up, I have to look up how they do the programmatic startup. And I just start up the programmatic way to the open web being. So if you're using something else, you have to look how that is done. But doesn't really matter. So you just do the startup. And then you'll just retrieve any CDI object from the CDI API, right? So you can just go Java Enterprise inject sp CDI, call current, call select, and then you can say what's the bean, but the CI bean that you want to retrieve. And then you have an instance on that, and then you just call whatever method you like. So now you have an instance of number resource API, so then I can call just that get number, right? So if you see number resource API, you have the get number method. Now the cool thing is, since this is now using MicroProfile fault tolerance, I can just kill my servers over here, and if I call this invoker, so now that's not running. So what's going to happen is the circuit break is going to kick in. So the fallback is also going to kick in. So I have here an old version that's using a retry. Doesn't really matter. Let me kill that one. But the idea here is now you can create your own client in Java, and you can pretty much hand it over to any other team, and they can use it on GraalVM with their language of choice, and you only have to write the client a single time. And then you can even have an intelligent client. So I have here some retries, right? So it's retrying the service if it doesn't work. But let me comment that one. And I'm just going to rebuild that jar. So that's done. And now let me call the Python version again. And now you just had the fallback, right? So now I can create my own client with the fallbacks, circuit breakers, retries, all nice, all with all the annotations, all as a single jar, and then you hand it over to a person that's using JavaScript, and they can benefit from all of that by using it on GraalVM. Okay. So another thing is, I don't only have like 12 minutes left, but the other thing I want to show you is about a few more things about Polyglot. So you can wrap stuff with JS, Ruby, Python, or R script, and you can expose those services using MicroProfile. So the idea here is going to do the opposite. I'm just going to call stuff from these languages and run it on Java. So then everything's going to run on the same VM. So the interesting thing about here is that you have a huge ecosystem to explore. So for instance, in the company that I'm working right now, we do a lot of natural language processing. And then we found out that most of the libraries to handle those cases are written in Python. So it will be a pain for us to have to pick up all the Python code and expose that to services and figure out how to then do all security, all fault tolerance. Because if you go, for instance, to Python, you don't have like a framework where you have all these problems solved. You have like different libraries to do all these kind of things. So it is interesting because now you can pick up MicroProfile, which gives you all of this, and then you can just wrap that particular piece of code that you want to use on Python or R or whatever other language, and then you can expose that one using the standard endpoints that you all know and like to implement. So the hero here is that we use MicroProfile to expose these services. And so Python is one of the cases we're using natural language processing. For instance, for R, we also using this to do maths, statistics, and forecasts. So we have a lot of data science people that like to try to convince them to use Java. Most people they won't like to do it, right? They like to keep their language of choice. But we solved that issue. So one of the things that I want to show you first is, so remember that I was running the number API native. So yes, here it is. And that was generating a random number. So if you look into the JavaScript version, you see here that's doing a left path, a math floor, math random, blah, blah, blah. And the Java version you actually didn't see that. There is something called number generator.generate. So what generate does? Let's see. So generate does was actually using the Polyglot API from GraalVM and is using the JavaScript version to generate that number. Right? So it has, if you look here, as so you have to import a library from GraalVM, which is this one called over here, this GraalVM SDK. You're only able to run this on GraalVM. But now you can just say context.create, and you pass in what's the language that you want to use. So in this case, I'm going to use JavaScript. And then you can just do context eval, and you can just type whatever language you like, or whatever the language that you just chose to create. And in here, I'm just using inline code, but you can also import scripts directly. So you can just import a .js file, or a .r file, or a .ruby file, and I'll show you just that. But don't you see something interesting over here? Is this is running as a native image with JavaScript in it. So it's running native image Java and JavaScript all along. So a lot of people, maybe if you've seen some of the presentations where they show you the native image and it's super small. So usually if you're running without JavaScript, it will be like a 14, 16 meg executable size. This one is actually 71 megs. Because when I run in the native image, I'm also including the JavaScript interpreted with it. So it's actually shipping with JavaScript inside to be able to run the JavaScript code that you have. And if you look into the command, they actually build the native image. You also have something there saying native image language JavaScript, because I want to include JavaScript. And then there's a bunch of other flags that I'm not going to discuss here, but you get the idea. Now, for my final demo, I'm going to show you here, this is a very small thing, but I can show you a more complicated sample. So I created here what I call a calculator in R. So this is just an enum. The enum has a couple of names, and those names bind to a script written in R, which perform the function or the operation for my calculator. So as you can probably guess, the add is going to add two numbers or two parameters, right? And the same thing for all the other operations. So divide. So you get the idea. But this is simple, but can be as much complicated as you will like. And now on this enum, what you'll see on the API is, again, I'm using the Polyglot API from GraalVM, and instead of using the context and passing in the script that I want, just saying, I want to start a source. I want to build the source from this URL. So basically, is loading the R script from the context class loader, and then just creates a context with the R script in it. Then I can just call eval, and just to evaluate the source to compile it. And finally, I have a method called execute that's actually going to execute the actual script. And if you look into this function, this API that they retrieve that they give you is something called value. So it's a very simple API. It doesn't have too many things to worry about. But it only has like one method that you have to worry. It's called execute, and has like a var args that you can pass in whatever argument you want to your R function or your Python function or wherever other function you like to call. And then you just have to do a conversion, right? So because GraalVM doesn't know what object is going to return from that function, so it just returns as if I extract that one, it will just return as a value. So it's a wrapper object. So if you want, for instance, to have that as a number, it'll just say execute as a number, and then it will just cast it to a regular Java number. And now, what I did over here is I created a resource endpoint, right? So this resource endpoint is just a path with endpoints, right? With a get, post, put. Well, actually, it only has post, but you can pretty much have those methods in there as well. And they're just doing a bridge to call the enum that's going to execute the function in R. So what I'm doing over here is I'm exposing that R script using plain JAX-RS. And I can bridge between those languages, and I can now pick up, yes? Oh, 5 minutes, yes, sorry. And I can expose all of those functions using that REST endpoint. Now, think about these as a second. Now, if you're trying to do something in R and you want to create an open API file to expose your data presentation, that's hard. If you want to do security, that's hard. If you want to do health checking, metrics, that's hard. But now, if you wrap it in a MicroProfile, that's easy because you just come over there and put a couple of annotations and you're done. Right? Do you guys believe this will work? Well, of course, if it won't, I won't standing here, right? So now, I'm actually, and there's a couple of Quarkus sessions, so I'm actually running these on Quarkus. And so I already have that compiled, so I have java.jar, that's target calculator runner. So now, yeah, Quarkus starts very quick, just 1 second. And now, I can curl that endpoint. And I'm just calling calculator/as and passing an x and a y with a 1. So the first execution, because I haven't things cached, takes a little longer to create the R context, but that can be fixed with some initialization code. Doesn't really matter for demo purposes, but you get the idea. So now it returned 2, so that seems to be fine. So if I call that again, now it's fast. So it just took a little bit longer to do the thing. So if I'm changing, so that seems to be working. So let's call multiply. Well, that seems to be OK. And supports also floating point. But now you get the idea and the potential of what you can do and achieve with GraalVM and the Polyglot stuff, right? And you can also build this as a native image. I just haven't built that yet, but you can build as a native image and then run it as a native image as well. So, and that was the demo. So let me share some of the final thoughts about all of I'll show you over here. So there are some limitations on GraalVM. So right now they only support in Java 8. Java 11 support will be coming by the end of the year, according to their roadmap. But as you know, roadmaps change, so we're not sure if that's going to happen, especially because we are so close to the end of the year, but let's see. There is some lack of tooling, so you've seen a lot of the commands that I did, and I did shortcut a lot of stuff that I haven't shown you to basically generate the images, to do a lot of compilation. But those things are now being handled by frameworks like Quarkus and Micronaut, which are handling that for you. So you just have to worry about developing your stuff and have it run. So then that also means that you have to manage your own class paths and all those commands. But I wanted to show you that over here so you can have a picture on what's happening under the covers. But now those libraries are going to handle that for you. And there is still not much information around. So since things are evolving very, very quick, documentation gets outdated pretty quickly. So you end up finding something on Stack Overflow or GitHub, and then it doesn't work because it was like 2 versions ago. But things are becoming more stable, and you're now able to do a couple of things that, like I show you over here, which I think they are interesting. Now, a couple of challenges. So Python support is still on early stages. They do support most of the language itself, but their libraries are still getting there. A cool thing is the GraalVM team is very supportive of your work. So if you're trying to do some crazy stuff and that's not working, you can tap them out, and they'll try to help you as much as they can. So again, not all libraries are supported yet. So most are, and a lot of them are out of the box. But if the library is doing something crazy, it might not be working. So maybe the GraalVM team has to have a look into it. So you can just query them and say, hey, this is not working. Can you please figure that out? And upgrading, just when I did upgrade a lot of stuff, sometimes it broke a lot of things. But I mean, that's what it means living on the edge. So you have to take care of that. So do I believe this is production ready? I think they are OK for JVM and JavaScript languages. Other languages may not work fully yet. For instance, Twitter is already running this in production for performance improvements. And I'm also running that in production as well. So just a couple of weeks ago, we were running our stack with Quarkus, GraalVM, and R. And it's working fine for us. So maybe you want to try that out. And just to finish up really, really quick, I think GraalVM can improve how we build microservices, especially all this Polyglot stuff, and to do all of the integration that sometimes is painful to do on this world. So you can pick up your favorite language, and you get rid of all the boundaries, right? So you can pick the library that you want to use. Some of the cases that I show you, you have the client library, you can just give it away, and people can just use it. So these are some of the resources. So all of the samples that I show you are here on this GitHub page with instructions to run it. So you can just try it out yourselves and see if that works for you. And since we're not out of time, I don't have time for questions, but please find me outside, and I'll be happy to answer any question to you. So yes. So thank you so much for coming to this session. I hope that you enjoy it.